This video is on Unit 4, Polynomial Functions, Chapter 8, Intro to Polynomial Functions, Lesson number 4, Writing Polynomial Functions from Roots. This lesson is one that we have done in a previous chapter. It was in the Quadratics Extra, so Chapter 6. You've already seen this. In Chapter 6, working backwards to a quadratic is what we did there. In this particular lesson, we're going to work backwards to any kind of polynomial function. So it might have a degree of 2, it might have a degree of 3, it might have a degree of 4, it could have a degree of 5, and so on. So it's the same exact steps that we saw before, but our problem is going to have a higher degree than it did when we were studying quadratics. So the bullets here, writing polynomial functions from your roots, you will use the roots or the zeros, which were the solutions, to work backwards to find the original polynomial function that has those solutions. Remember that your roots or zeros are what x is equal to. Those are the points where the function hits the x-axis. Okay, so those are our actual answers where it hits the x-axis. Factors are the binomials that multiply to create that polynomial function. Complex roots and irrational roots come in pairs. So again, they come in a positive and a negative. So it might be a positive and a negative I, or a positive and a negative radical. Okay, so again, the factors might be x plus 5, and if a factor is x plus 5, then the solution would be x equals negative 5. Those two things are related, and it's all about vocabulary. So let's talk about how to work backwards, how to write a polynomial function. Step number 1 says to set x equal to each root. Step number 2, if the root is a fraction, make sure that you multiply the equation by the denominator. Then in step 3, we're going to use opposite operations to get a 0 on one side, and these are your factors. So we go from the roots to the factors by getting a 0. Multiply the factors together, and then write in function notation. So looking at example number 1, it says write the polynomial function with the given roots. So again, what you have here are roots or zeros. And we're going to turn those roots or zeros into factors by taking each one and saying x equals the negative 3, and then add the 3, and we get x plus 3 equals 0. X equals 1/2. Now this is a fraction. This is a fraction. So before I can subtract, I need to multiply by that denominator to get rid of the denominator. Now I can subtract the 1 to get the 2x minus 1. And then the last one, x equals 1 minus the 1, and we get x minus 1 equals 0. So these three things that I just created here are the factors. So we've changed from roots to factors, and then we're going to take those factors and we're going to start multiplying. Just like we learned in lesson number 2, or 1, lesson number 1, we can only multiply 2 things at a time. So I'm going to put brackets around the first 2, and I'm going to concentrate my efforts there. So x times 2x is 2x squared. X times a negative 1 is a negative x. 3 times 2x is a positive 6x, and 3 times a negative 1 is negative 3. I'm going to combine my like terms. I feel like a broken record here. When you guys multiply a binomial times another binomial, the two middle terms should be alike. Negative 1x plus 6x is a positive 5x minus 3. Now we've got a trinomial that we got to multiply by that x minus 1. So same process. We're going to distribute 2x squared times x is 2x to the third 2x squared times negative 1 is a negative 2x squared. Now the 5x. 5x times x is a positive 5x squared. 5x times negative 1 is a negative 5x. And then last but not least, the negative 3 times x is a negative 3x. Negative 3 times negative 1 is a positive 3. Now the very last step here is going to be to combine our like terms, making sure that everything is in standard form. The largest exponent is 3, so my 2x cubed goes first. Then I'm going to combine my squares. Negative 2x squared plus 5x squared is a positive 3x squared. Y'all, again, all we're doing is combining like terms. We're adding them together, so exponents do not change. Negative 5x minus 3x is a negative 8x, and then the plus 3 on the end. Don't forget to make this a function by putting f of x out front. So that's example number 1. Let's look at example number 2. Now looking at this, it looks like we just have two things. But 2i is a complex root, so that means that there's also a negative 2i there. Don't forget. So again, we're going to start with changing those roots or zeros to a factor. And I'm going to use this space to the left. I got x equals the negative 2/3. We're going to multiply both sides by 3 first. And we get 3x equals the negative 2. Add the 2. And we get 3x plus 2. So there's one of my factors. Take the 2i, x equals 2i. Subtract the 2i. X minus 2i is another factor. And then last one, x equals negative 2i. Add the 2i using those opposite operations. And we get x plus 2i equals 0. So there's my third factor. Take your factors and multiply them together. All right, so make sure you're listening to this next thing. This is very important. When you are looking at three things like we've got on example number 2, you want to make sure that you are multiplying like things together. So I'm going to choose to multiply first the two sets of parentheses that both contain an I. Those need to multiply first. Do that first. X times x is x squared. X times a positive 2i is a positive 2xi. Negative 2i times x is a negative 2xi. And negative 2i times a positive 2i is a negative 4i squared. So I'm going to go through this again. We've done this before. The two middle terms cancel. But negative 4i squared is going to simplify. I squared is negative 1. Negative 1 times negative 4 is a positive 4. So that last term changes from negative 4i squared to plus 4 because of the I squared. So this is going to simplify to x squared plus 4. And then we need to multiply that times the 3x plus 2. 3x times x squared is 3x to the third. 3x times 4 is a positive 12x. 2 times x squared is a 2x squared. And then 2 times 4 is a positive 8. Now, this is not okay. It's not in standard. The terms are in the wrong order. The x squared should come before the x. Don't forget the f of x. If you want to, you can just make it a y instead of an f of x, and I'm okay with that as well. All right, maybe one more. Let's look at number 5. Number 5 has a radical. And radicals also come in pairs. So that is a positive radical 3 as well as a negative radical 3. So technically, I have 4 roots here. I have 4 zeros. And because I have 4, I know that in my final answer, it's going to say x to the 4th. If you have 3 roots, it's going to say x to the 3rd, and so on. So we're going to start with the 2. X equals the 2 minus the 2. And we get x minus 2 equals 0 for my first root. X equals, I'm going to do the negative 4/5, keeping like things together. Multiply by 5. 5x equals negative 4. Add the 4. And there's another root. Now the radical 3. X equals radical 3 minus the radical 3. And we get x minus radical 3. And x equals negative radical 3. Add the radical 3. X plus radical 3. So these are my last 2. So we're going to take the x minus 2, the 5x plus 4, the x minus radical 3, and the x plus radical 3. Now, for one like this, the order in which you do this is definitely going to make a difference in how easy or how difficult this becomes. I would multiply the first 2 things together because they're alike. Neither one of those has an I, neither one of those has a radical. And then I would multiply the second 2 together because they both have a radical. So x, starting with the first 2, x times 5x is 5x squared. X times a positive 4 is a positive 4x. Negative 2 times 5x is negative 10x. And negative 2 times a positive 4 is a negative 8. Combine our like terms. 4x minus 10x is a negative 6x. Bring down that minus 8. So that's one of my products. Now let's do the next 2. X times x is x squared. X times a positive radical 3 is a positive x times radical 3. The next one is a negative radical 3 times x. That's going to give me a negative x radical 3. Now the last one, again, is always tricky for you guys. When you take a negative times a positive, first of all, it's going to be a negative. And when we take a radical times itself, radical 3 times radical 3 is equal to 3. Radical 5 times radical 5 is 5. Radical 7 times radical 7 is 7. The radicals go away. And as a matter of fact, once we combine our like terms, all of the radicals are going to go away. And this becomes x squared minus 3. Now the last step here is going to be to take those 2 and multiply them together before we can finally come up with our final answer. 5x squared times x squared is 5x to the 4th. 5x squared times negative 3 is negative 15x squared. Now for the negative 6x. Negative 6x times x squared is negative 6x to the 3rd. Negative 6x times negative 3 is a positive 18x. And last but not least, your negative 8 times x squared is negative 8x squared. And negative 8 times negative 3 is a positive 24. And all we have left to do at this point is combine our like terms and put it in standard form. 5x to the 4th is our first term because that's the biggest exponent and there aren't any others. For the cubic, there's only one x cubed, so bring down your minus x cubed. Then the x squares, negative 15x squared minus 8x squared is going to give me a negative 23x squared. Then our x and our constant. Put an f of x in the front. F of x equals 5x to the 4th minus 6x cubed minus 23x squared plus 18x plus 24. Again, if you don't put f of x, at the very least put a y equals. And there's our answer on number 5. The process is the same for these others that I have skipped. So those are our notes for lesson number 4 on writing polynomial functions from roots.